It sends the signal to the left atria. Does everybody see that? That's the first impulses, okay? The first impulses from the SA node are to the left atria. Why?
Because it's the pump the blood to the rest of the body.
Do what?
Because the left side pumps the blood to the rest of the body.
That's what it gets filled.
Okay, in the atria, blood is filling. Now remember, when blood's returning, whether on the right from the systemic and the coronary, or the left from the pulmonary, it's happening at the same time. Brian?
Well, it looks like that's what starts kind of the chain reaction of the rest of the heart. It goes SA node, then it goes to the AV, and then from there it fires the rest of the pulse. Basically, it's just the start of the
Now, look at it this way. If the atria are filling at the same time, and then they're going to take, and the blood has to go from the atria to the ventricles at the same time. When the contraction happens, that means the blood is pushed out at the same time. I need because remember, we got 4 chambers, 2 atria, 2 ventricles. I need my atria to function almost at the same time, and my ventricles to function almost at the same time. So, if my SA node serves my atria first, then begins to move to the ventricles, this gives me a nice movement of the impulses that pretty much look like they function together, where it'll go for that heartbeat. All right? When in reality, it's every cell independently working, but they are so well coordinated, it makes it look like it's one action. So, in this conduction system, that SA node fires, and it's going to send the impulse to the left atria. When it comes to the left atria, the next job is to move to my AV node, because my atrioventricular node, what do you notice about, they're trying to show its nerve-like pathway, even though it's not nerves, okay? It's a nerve-like pathway. What do you notice about that pathway that they're showing coming from the AV node?
It runs through the actual muscle.
That one has a connection. It has to move through that interventricular wall where I find my myocardium. And it not only has to make its way there, it has to travel down, around the apex, and back up, because it needs to follow my cardiac cells. Does everybody notice that? Because if the case is that my cardiac cells do this number and move up and that up, I need to have the impulse, because the impulse is going to make a change in the flow of ions across the membrane of these cells. If I do that, what have I made them do?
Contract.
Contract. So when my SA node fires, crosses to the left atria, makes it to the AV node. AV node, this used to be called the bundle of His. They now have given it some other name. I just wish they'd leave stuff alone. But anyway, it has to travel to my bundle of His. Note how it has a pathway that it branches. One side travels down and up the right side. One travels down the other and up the left side. And it gives off these nerve-like extensions meeting the cardiac cells. They call it the network, okay? And therefore, when the impulses travel and makes these cells act, the heart contracts. Yes, no, maybe.
Yes. Now they're running on those muscle hillocks that manage the.
You talking about these right here?
Yeah.
Okay. Now, remember, these papillary muscles are connected to the chordae tendineae, the tendinous cords, connected to the flaps. What is it that as my atria are filling, are these flaps open or closed?
Close.
They are closed. When pressure increases, that's going to make these flaps open. When those flaps open, blood begins to move into my ventricles. I need that blood to move from the ventricles into their great vessels. So as the SA node fires and has is passing its impulse, and from the apex, that's where the contraction will start, okay? And it will twist. And as it twists, pushes the blood into the great vessels, and the whole process starts over again. Does this make sense? Stop me now. Because I can tell you with 110% assurance, you are going to encounter a person's heart when you're treating them. How can you not? Unless it's not beating at all. And I have found out that the heart can still be passing an electrical impulse and the person's dead. Just saying. I can guarantee at some point you're going to encounter your patient's heart. Any questions? So, like I keep saying, the heart is innervated, does not depend on a nerve impulse to function. Because the heart is an organ, which means it is viscera, it's innervated by my autonomic nervous system, the ANS. Therefore, it's going to have innervation for both sympathetic and parasympathetic information. If you remember, sympathetic is the part of the ANS that speeds things up. Parasympathetic begins to slow it down. We know that the ANS can be affected in many ways. It can be affected by emotions. It can be affected by stress. There are lots of factors that can affect the autonomic nervous system. For example, last night was Halloween. Did any of y'all get scared? Well, I mean, I totally forgot it was Halloween, so I went to the beauty shop yesterday morning. Everybody was dressed up because I don't have to worry about it. Because where I live, I don't have any trick-or-treaters, you know. So I didn't think about it. But comically, all right, you know, the little kids come up trick-or-treating, and then you're supposed to be, oh, you see, you know. And I got this picture. Oh my goodness, my grandchildren's mother sent me a picture of my grandchildren. And if my granddaughter was trying to be, do you guys remember the movie, The Addams Family?
Mm-hmm.
Okay, I think her name was Christina Ricci that played the little girl that was
Wednesday.
the witch or whatever. My granddaughter looked exactly like her. I was like, if she is trying to pull that off, she did a really good job. I mean, even the expression on her face and everything. And I was like, oh, man. Actually, kind of scared me a little bit. But anyway, you know, the fear, you know, fight or flight. And that's what happens with the sympathetic. But do you happen to remember that when the sympathetic division kind of gets ramped up, one of the things it'll do is hormones, like the epinephrine and so forth, that can have an effect. Do you guys remember how we had the thoracolumn, all that sort of stuff in the spinal cord? For the sympathetic, and do you guys remember how we had preganglion and postganglion fibers? Okay, in my sympathetic, the way that we're going to have an effect from the sympathetic division, the preganglionic fibers, they go to that chain ganglia that ran along the spinal cord, okay, and some of them, they would go up to the cervical, some of them would go down. And when we look at that, once they reach that ganglia, the ones that are post fibers pass through an area called the cardiac plexus. Now, if you remember, plexus means a group of nerves. These are nerves that are making their way to the heart. So from the sympathetic division, post-ganglionic fibers are passing through the cardiac plexus. They're going to make their way to the heart, and look where the fibers terminate.
So the cardiac what is the cardiac plexus then?
A grouping of nerves that you will see external to the heart. And they're going to make their way to the two nodes of the heart.
So is a plexus just a gathering of nerves?
Mm-hmm. It's a grouping of nerves, nerve fibers. They're terminating on my pacemaker. The AV node can make the heart beat when the SA node goes bad. You don't want that, but it can, okay? So those fibers are terminating at the area that sets my heart rate. What happens to my heart rate in the sympathetic response?
Speeds up.
It speeds up. Now, it terminates at my SA node. That means it's going to affect my pacemaker. Therefore, the beat of the heart is going to go higher than the regular norm. But like I said, that number is just a norm value of that 75 beats per minute. We're going to have it go to the cells of the atria and the ventricles. I'm also going to have innervation